Yes, it's Dr. Takalani Enos Marubeni, yes.
All right, thank you so much, sir, and welcome. Dr. Tinaro, do we know the whereabouts of Dr. Kirui?
Let me just try to call him and see if he is around.
Okay, please do so, as we shall await to hear from you.
Okay, thanks.
Okay, good morning once again, colleagues. I see Dr. Kirui has joined the meeting. Welcome, Dr. Kirui. My name is Simon Mnyageni Mulele, and I welcome you to this session of today as we continue to celebrate the role of basic sciences in the modern world. So I believe also today, just like yesterday, it will be a very interesting day for us as we have speakers from the University of the Western Cape in the form of Dr. Marubeni. Also later on, we will listen to Dr. Wanda Jupiter from the SABC, and later again, we'll listen to Professor Mapanga from the CSIR. So without wasting any further time, I'm going to hand over to Dr. Kirui so that he can introduce our speaker. Over to you, Dr. Kirui.
Thank you, Chair. Thank you. And thank you, colleagues, for waiting. So I start by saying good morning, colleagues, and good morning, our presenter, Dr. Marubeni. Yes, mine is to introduce Dr. Marubeni. Takalani Marubeni is a former student of ours, so we know him from long ago, since he did his PhD in physics and mathematics at this university. He proceeded to do a PhD honors in physics at the University of Limpopo, and then the Master of Science in Space Physics at the Northwest University. Dr. Marubeni now proceeded to do more in his chosen field and went to register for PhD in astrophysics. So his thesis topic was multi-wavelength study of powerful high redshift radio galaxies. That is what Dr. Marubeni did for his PhD. at the University of the Western Cape. Dr. Marupini also is interested in reaching out to the youngsters in high schools, and so he registered for postgraduate certificate diploma in education, PGCE, at UNIVEN. Currently, Dr. Marupini is a postdoctoral fellow at the University of Western Cape. His research interests are on observational constraints on galaxy formation and astrophysics. So we thank Dr. Marupini for devoting himself to look at the stars. I was asking him another time and say, now, I hear that some stars are born and others die. So by and by, he will tell us more, maybe not today, but other times. So there's a lot to learn from him in the stellar space. So thank you, Marupini, for coming to give us a talk. And we look forward to listening and learning more so that we become all round, not only looking down on Earth, but up in space also. Thank you, Marupini, and we are really excited to hear from you. Having grown with us, you are one of our team members, actually, who have grown, and of course, you may choose, opportunity. This may still come and you tell us more and more and more. Thank you so much. Thank you, Chair.
Thank you so much, Dr. Kurui. Without wasting any further time, Dr. Marubini, can you please upload your presentation and continue with it? Thank you.
Thank you, Chairperson. Thank you, Dr. Kirui, for introducing me. And once more, I would like to promise Dr. Kirui for 3 more stars. He knows what do I mean by saying that. So the stars are growing. Now we are having more than 10.
I'm excited. But they are billions. Why give me only 3?
No, you need to work very hard to get them. So 3 actually it's even a lot. So
thank you.
All right.
Thank you.
I will start by saying to you, my apology for not coming with something to upload, because I realized that this is just more of talk. I didn't prepare it in a way that I'll be giving out slides. I failed to get more connection towards slides with respect to what I'll be saying. But however, this does not hinder us from getting information and brainstorm our mind with what I'll be giving you or what we'll be sharing. My topic is the importance of basic sciences in space science for sustainable development. And what came to me during when I get this topic was, how can we encourage young people to pursue scientific jobs so that every nation has sufficient supply of engineers, scientists, and medical professionals? How can we make sure that people who do not intend to be scientists are nonetheless knowledgeable citizens who understand the scientific method, its uses, and its limitation? The study of science in the classroom ought to inspire interest and joy. Additionally, pupils, particularly the young ones, are important agents in bringing about a better society. Not only should students be taught science and technology, but they should also be exposed to situations that will motivate them to use their knowledge to improve the world. I would like to take your attention to be aware that a resolution designated 2022 as the United Nations International Year of Basic Sciences for Sustainable Development were adopted by the United Nations General Assembly at its 76th session. Now, after I've said that, what is basic sciences? What are the basic sciences? The basic sciences are defined as the scientific discipline of mathematics, physics, chemistry, and biology, known as life sciences. They are called basic sciences because they provide a fundamental understanding of natural phenomena and the process by which natural resources are transformed. All the goals in this cannot address could potentially benefit directly or indirectly from the use of space research, technologies, and data. Astronomy, aerospace, engineering, space, medicine, and astrobiology are a few of the scientific fields that are frequently included in the field of space science. It also covers other fields that deal with space exploration and the study of natural occurrences and physical substances in space. Satellite Earth observation, satellite communication, and satellite location are terms used frequently to describe space technologies. Space and technology are essentially to a variety of scientific disciplines, including astronomy and Earth observations, weathering forecasting, remote sensing, GPS, satellite television, and communication systems. In this speech, the benefit of international research cooperation in this field are discussed, along with studies on how space technology could accelerate sustainable development. It also outlines ways that space science and technology might be used to sustain development goals, especially in the areas of telecommunications, health, monitoring natural resources, averting humanitarian crisis, ensuring food security, and lowering disaster management. It also examines how technology advances that lower the cost of using space-based applications and partnership between local, national, regional, and international stakeholders may enhance the acceptance of goals-relevant applications, especially in the developing countries. Now, the first item I would like to talk about is agricultural food security. Precision agriculture, contemporary agriculture, and agricultural innovation can all benefit from space technology, due in large part to the exorbitant expenses associated. The use of technologies for farming and the management of natural resources used to be mostly restricted to industrialized nations. Through programs like Open Data Cube, open access to geographic data, data products and services, as well as the decreased cost of geospatial information technology. Facilities have recently sped up the use of space technology worldwide, particularly in developing countries or nations. Agribusiness, international organizations, and farmers can all benefit from agriculture goods and services offered by space research. For instance, the World Meteorological Organization offers offers weather and drought forecasting services to farmers, herders, and fishermen through its agricultural meteorology program in order to support sustainable agricultural development, boost agricultural productivity, and support food security. In addition, the Hazardous Precision Farming project, which is in Turkey, creates a software and makes fertilization and create a software and maps for fertilization, as well as distribute satellite photos and analytical data to farmers online. Application can facilitate crop monitoring from space at national level, employing algorithms for land use and cover and publicly accessible satellite data. For instance, Statistics Canada was the first national statistic office to use a remote sensing model-based approach to estimate agricultural yields in place of WORM survey in 2016. A cloud-based crop monitoring platform called Crop Watch Cloud also enables nations to conduct independent crop monitoring and early warnings related to food security without investing in establishment and operating cost. Earth observation can help local, global initiative, can help local and global initiatives that aim to help people who are at risk of food insecurity through the Integrated Land Resources Information Management System and the Global Agroecological Zones Data Portal. The utilization of remotely sensed data is essential to the efficient monitoring of agricultural production. Several nations provide worldwide forecasts and evaluations based on space applications, either along or collaboration with other nations. For instance, United States and global projection for wheat, rice, cash, grains, oilseeds, and cotton are included in the monthly report of the United States Department of Agriculture on estimates of global supply and demand for agriculture. Application to health. Global health goals have benefited more recently from the use of space-based technologies. Space science technology and applications including Earth observation and remote sensing, telecommunication, positioning and tracking, and space-based research play a crucial role in supporting decision-making, improved care, education, and early warning measures, according to a study in the public and global health fields. Monitoring disease trends, understanding environmental triggers for disease transmission, predicting risk areas, and identify places that need disease control planning are all done with the help of remote sensing technologies. For instance, a geospatial-based early warning system for malaria has prevented 500,000 new cases in 28 countries. In 2018, cholera forecasting in Yemen was done using the Data National Aeronautics and Space Administration, known as NASA satellites, with the accuracy of the rate of 92%. In addition, the World Health Organization maps challenging to access places using digital elevation models provided by the Japan Aerospace Exploration Agency in order to put effective safeguards in place for infectious diseases, including polio in the Niger. One industry where the use of satellite communication and remote sensing is essential is public health. The infrastructure of the comprehensive exchange of health information includes satellite communication. In this industry, Telemedicine, telehealth, disease surveillance system, and health mapping are some of the major applications of satellite technology. Space technology can facilitate medical research that will otherwise be challenging to conduct in a terrestrial context. Beyond monitoring infectious disease or facilitating access to healthcare in remote areas. For example, innovation medicine designs for cancer, infectious diseases, and lifestyle-related diseases can be supported by high-quality protein crystal generated in microgravity environment. The other point which I would like to look at is humanitarian crisis prevention and disaster risk management reduction. Globally, 1.3 million people died as a result of climate and geophysical disaster between 1998 and 2017. And an additional 4.4 billion people were forced to flee their homes, sustain injuries, become homeless, or require emergency assistance. Application of space science enabled technology have emerged as a key component of local, regional, and national catastrophe risk reduction initiatives. Globally, the Sendai Framework for Disaster Risk Reduction 2015 to 2030 emphasizes the value of encouraging access to reliable data and utilizing space information through geospatial and space-based technology, along with science, climate observations made possible by remote sensing, to improve measurement tools and the collection, analysis, and dissemination of data. Earth observation, which utilizes remote sensed satellite images and increasingly high-tech instruments, such as on floating buoys to monitor ocean currents, temperature, and salinity, land stations to record air quality and rainfall trends, seismic stations to track earthquakes, environmental satellites to scan the Earth from space, and the use of sonar and radar to observe fish and bird populations. Aid in the detection and monitoring of disaster risks, particularly in the event that a disaster does occur. For instance, during the 2017 Atlantic hurricane season, precise meteorological predictions and enhanced communication helped coordinate evacuations and save lives. In addition, nations at risk from cyclones like Bangladesh and India have been spending money on modern meteorological services, improving early warning systems, and building embankments and cyclone shelters. The other point I would like to look at is natural resources and environmental management as this space science and how we benefit from space science. Earth observation is a crucial tool for managing the environmental and natural resources. It is very important for attaining the goals and assessing development. It provides data to enhance the management of freshwater, forests, fisheries, and agricultural production. It can also be used to track environmental hazards like wildfires and unlawful mining, logging, and poaching. In addition to helping to manage water resources and preserve forests, Earth observation data from satellites can be used to address a number of difficulties connected to air pollution. For instance, monitoring precipitation can help with dealing with water-related calamities like floods, typhoons, and landslides. Using the satellite data from the Global Precipitation Measurement Project and the Global Change observation mission has JAXA, which is the Japanese exploration, has built a precipitation monitoring system that provides maps of the world's rainfall. Brazil also uses photos gathered by the National Institute of Space Research to monitor its forests, despite the difficulty posed by the immensity of the region to be watched. The Biomass project uses nano-satellite technology to keep an eye on the condition of the Amazon jungle. Monitoring unauthorized mining operation can be done using Earth observation techniques. Remote sensing can be used to track unauthorized sand mining by keeping an eye on natural fluctuations in river and sand flow. For instance, sediment discharge rates at river exist and primary materials can be determined using satellite data from NASA Gravity Recovery and Climate Experiment. The European Union Copernicus initiative makes use of satellite photography to monitor and manage the raw materials and the natural resources sector. Finally, the Earth observation can be used to track environmental conditions and issues that are unique to a particular nation, like those related to snow, ice, and glaciers. For instance, an Austrian business spread-headed effort to build and deploy a common European services for monitoring snow and land ice as downstream service for the Copernicus Earth Observation Program, with funding from European Union Horizon 2020 program. Now, let us try to connect the unconnected. In many places of the world, especially in rural or mountainous regions with low populations, access to terrestrial networks is restricted or non-existent. In these regions, satellite technologies, either by themselves or in combination with other technologies and existing infrastructure, are well suited to deliver broadband services. A new set of network technologies can frequently lower infrastructures needs and give more cost-effective service delivery alternatives and traditional networks infrastructure used for broadband connectivity. For instance, Bangladesh recently sent into the orbit a communication satellite that broadcasts television and radio programs, as well as internet, telemedicine, and distance learning services for people in rural areas. Low and medium altitude satellites, various aerial devices, and the creative use of unused radio frequency spectrum are just a few of the cutting-edge technologies that could influence the growth of telecommunications connectivity. For instance, the creation and upcoming use of fixed satellite services in non-geostationary orbit has the potential to expand access to broadband infrastructure and close the digital divide, especially for people living in rural areas. Additionally, private sector business can offer worldwide internet access via high-altitude balloons and non-satellite constellations. Now let us look at various applications. Other space technologies such as satellite positioning can support transportation and fleet management, as well as scientific applications like measuring the effect of earthquake, climate change, and space weather on Earth. These applications go beyond satellite Earth observation and satellite communication. More broadly, applications in urban planning, education, poverty mapping, and other fields related to sustainable development goals can be supported by space science and technology. Using openly accessible and non-proprietary data, recent research has shown the ability of satellite photography and machine learning to forecast poverty rates. For instance, the World Bank studied the use of convolutional neural networks and high-resolution satellite images to forecast poverty rates. These techniques can also assist developing nations in estimating indicators of urban poverty, such as the percentage of the urban population residing in slums and unofficial settlements, and the rate of access to infrastructure and basic services. An emerging field of study is the use of machine learning to identify informal settlement. Whether these big data derived indicators will be as accurate as research and experimental projects suggest, however, remains to be seen. Big data has potential to supplement the evidence basis in developing nations where traditional statistics are not always available. However, over time, some algorithms may become more out of step with the underlying socio-economic reality. Application for space science technology can help with education as well. For instance, satellite communication might be useful for electronic education project. The United Nations Children's Fund supports the mapping of schools using satellite photography and machine learning. Research and development in the fields of science, technology, and innovation for use in science more potentially results in useful applications that are pertinent to the goals. For instance, battery storage capacity has improved as a result of United States-funded research for space applications. Now, in conclusion, space science technology and the data hold the potential to help achieve the 2030 agenda and the sustainable development goals. Costs are being driven down by new technological developments and collaborations between local, national, regional, and international stakeholders. Yet development is challenged by persisting bottlenecks, including the lack of awareness of the benefit of space technologies, limited financial resources, and technology and skills gaps in developing, using, and adapting space technologies. National and regional policies and strategies to support space science technologies and the data for achieving the goals could include effort to build upstream and downstream capabilities, improving infrastructure, and increase public awareness. Develop policies for open data and open science for geospatial data, and leverage public-private cooperation on common goals for space science technology and data for achieving the goals. The international community is encouraged to develop a collaborative agreement that take advantage of the individual competitive advantage of countries, encourage regions to develop their own space facilities and develop space-related capacity by training space technology experts to be included in policy process, building upstream and or downstream capabilities, enhancing infrastructure, raising public awareness, developing policies for open data and open science for geospatial data, and leveraging public and private cooperation on shared goals for space science, technology, and data could all be included in national and regional policies and strategies to support space science, technology, and data for achieving the goals. The international community is urged to create cooperative agreements that benefit from each nation's distinct competitive advantages, to support the development of regional space facilities and to build up space-related capabilities by hiring space technologies specialists to participate in policy making. Thank you.
Thank you so very much, Dr. Marubeni, for such a well-researched and resultantly a well-informative talk that you gave here. Thank you so much. Yeah, at this point, colleagues, we open the floor for questions, suggestions, engagements, any other thing that you have on your mind regarding the talk that was given here by Dr. Marubeni. Floor is open for discussions, colleagues. We shall start with Dr. Mulaudzi, followed by Dr. Dinaro. Please, the floor is yours. Dr. Mulaudzi, you are still muted. Dr. Mulaudzi, can you hear me?
Sorry.
I'm sorry.
Okay.
I was talking while muted.
Okay. No, it's fine. Please go ahead.
Firstly, I want to thank Dr. Marubeni for such an engaging presentation, of which I think it needs all our faculty to be engaged, to be included also. Let me just drop this one. You talked about some of the models that can be done by the secondary schools. Can you help us with that? Because we also want to engage the learners at schools through machine learning where possible, of which they will be starting to do the earth observation through through machine learning. Can you assist us with that information so that we can carry it over? And this webinar series should not be ending at listening only, but the knowledge that we have gained must be put into practical. Thank you.
Oh, thank you very much for this question. What I can say with machine learning and this data science, I think where we can start is by, if we want to develop learners from secondary, one thing we can do is to make sure that they know how to use computers. For instance, in computer, we can still, we have this, the software which allows us to play with the data. Like for instance, if we use the Excel. So playing with the Excel with different numbers, that is just for instance, there's a lot of histograms we can still play, we can still draw. There's a lot of pie charts also which can still be played there. So we, at that lower level, I think educators and people who are helping learners should motivate them to use computers to analyze their data. Like for instance, if I can say to a learner, I've got five number of girls and 5 number of boys each of them, they wrote a test, and this is the statistics from the test. So instead of teaching learners to do those tasks by writing down, I think the other important things is to engage them using computers, is to engage them using maybe any materials which can help them to say, oh well, doing this with Excel or something, I can still get the result, and I can even draw the histogram or the pie chart. So those are the things which I think most schools we can still find ourselves making progress in that area without looking at the other stuffs which can be complicated to our learners and to our school premises.
Thank you, thank you, Dr. Marubini. Thanks, Dr. Mulauzi. Dr. Tinaro, please go ahead.
Thank you very much, Dr. Marubini. Your speech, your talk here on space science, I can tell I never have this.
I can't hear you.
To say.
I can't hear you. Please, I can't hear
you. You can't hear me. I'm not sure. Then, do the rest hear me?
Yes, now I can hear you. You can go ahead.
Yeah, your presentation is so wonderful, and I was just also wondering, in science in South Africa, are you many of such caliber people who are doing space science? Are you many? How many can you say? Are you happy with the numbers? Because this is quite a very important field. And also, then you did physics at what challenges do you think you had, and what recommendations would you give to universities like University of Venda Department of Physics in terms of what preparations or modules need to be maybe included in the program to make that journey easier? And also, what kind of intervention can be done to high schools to motivate our learners to take up this field as they go their studies? I really see this. I never, imagined. I know all these services, but I never linked them properly. But you really, unpacked them, and now we see how important this space science is. So those three, are we many in South Africa? Then what, advice or recommendation you give to the Department of Physics, say at our University of Venda, in terms of the relevant to properly prepare our undergraduates to take up these as they further their studies, and also what intervention can we do or can be done to the high schools or secondary schools to promote, the uptaking of space science by the learners as they go. Thank you very much.
Thank you very much for those three questions. The first question, it is saying, are you many? So we are many, but we are not enough. This is what I can say. Because if we can say we are now using the data, some of the data now are coming, we are having big data, and some of them now we are now going into the use of machine learning. We are going to the machine learning just because we are having the number. When we look at the number of people, they are less. So now we are saying, okay, can now computer help us to analyze this data? Can now computer be able to do this for us, so that at least because we are not that many. So, but however, there are people who are doing very well with this space science, and some of them, they are at SANTA, if you have heard of SANTA. And then some of them, they are at SAUD, and some of them are with the SKA, which is where I am from as well. So I'm doing my postdoctoral under the SKA. So I think one problem which we have as I think I will not be offending anyone by using the word blacks because I am also a black student. But the problem with I find with us blacks is that some of the times we don't want to challenge the unchallenged. We want the unchallenged to remain unchallenged until they are unchallenged. Why am I saying this? If I can remember well the time I started to do my master's in astrophysics, most people were saying you will never make it with astrophysics because you have even never seen anyone who is black, who is a black astronomer. And I had to stand up by myself and say, let me try. If I fail, at least I have tried. So I think blacks were still having this mentality of saying we should go for something which is easier for us, so that at least once we are done, I have the certificate. But we forget about the idea of what is it which I am contributing to the nation or to the South Africa as a whole. We just want certificates, and we end up having certificates because, of course, we'll go and do other fields of areas which maybe in a class we are even more than 120 to 200. Just because we are many in that, of course, we are happy. But I think it is hard time that we blacks, we stand up and say, we want to challenge those unchallenged ones. If I don't make it, at least I will end up somewhere. You can't just go unnoticed. So I think that is the problem. But the motivations which I can say to the University of Venda is that University of Venda stand a good chance in many spheres. This is how I'm going to support this. Most of the people whom I have said they are making it outside, like they are at Santa, they are at SAU, they are at SKA, are the product of University of Venda. So now the question is, why University of Venda is not taking their students and work with them for those projects? This is something which, if we can say, for instance, University of Venda can also have space science programs. University of Venda can also have astrophysics programs. University of Venda can have all those things. Why? Students or people who are working outside are products of University of Venda, which means I will stand to say University of Venda, what it needs to do is to take initiatives itself. But itself, I think, when it comes to the resources of manpower, as to what are the people, what are the products, South Africa, when it speaks of scientists in the arena of physics, we are speaking of students from Univen. In every sphere, wherever you go and say these are physicists, most of them, as long as they are blacks, they are from Univen. So that one, I have no doubt. It is now time that Univen has to take initiatives and say, if our people are going outside and make it well outside, why can't we bring it back so that we do everything also here ourselves? So what we can do with the secondary level, I think the secondary level, the other things which are important for them is to make sure that we do the outreaches. Those learners, they want to see people participating, engaging with them, knowing that I am talking to David Tenaro, for instance. He is a scientist and he is with us. He is doing the experiments with us. He is showing us that this is possible, and those people, I want to tell you something. Those people can be motivated only by seeing a member who is a scientist wearing a white coat. Just that. It to them is like, wow, this is a doctor, and then he's wearing a white coat, and then they are saying he's a scientist. That thing only, it's a good thing. So I will add by saying science awareness. outreaches. Those are the things which learners, and by doing that, we are now again reporting to the things which I have said, that how can we make people who are not destined to be scientists to understand and to know the methods it uses and its limitations. We can do that by going and make awareness to those learners outside. So everyone, whether you are a scientist, whether the learner is doing science or social science, the learner will be knowing how science operates and their method. So, which means it is another platform to say we can encourage non-scientists and a scientist to know how scientist works by just making awareness and outreaches. Thank you. I don't know whether it answers the questions you have asked.
Dr. Tinaro?
Dr. Mal, you have really, you have really, answered directly, and I'm very satisfied. And I think even people who are listening to Univen, we are eye opened. I think we will take it further. Thank you very much, and it is good that it is coming from you, who has passed it through Univen, and you are seeing what Univen is doing outside, and you are advising us like my colleague. Thank you very much for that.
Thank you so much, Dr. Marubeni. Thank you so much for those powerful words and building words. Yes, indeed, Dr. Dinaro, as you mentioned there, you've got former students who are challenging you to say, please work with us. We are there to assist. So let us please use them. The physics department is being challenged here, and I'm very much sure that they will take up the challenge. Let's now have a question from Madam Florence Murungwini. Please go ahead.
Okay, thank you, Chair. Thank you very much, Dr. Marubeni, for your talk. I've been listening, and I'm so happy to say that you shared very well, especially the applications of this space technology to various societal sectors. Now we know how we can link this space data to whatever we do within the faculty, especially. And after listening to your talk, there are questions to say, how do we engage secondary school students? Honestly, maybe partly, I was this week thinking of even engaging, maybe is not in Dr. Maluta and the Department of Physics as a whole, to say you have this one science center where students are coming there, high school students, they are enjoying the physics, science as a subject. So my question now is, we have all this space data that you have spoken about. We want it to be applied in society. We know in high school, these students are also doing geography as a subject. And those geography students, they are applying this space science data, and they are using the GIS and this remote sensing data. So my question now was to say, at the one science center, can't we add another laboratory where we have machines now, where some students who are not physics students, but geography students can also start enjoying the application of this space data that you are talking about? That is just my thinking and my comment. And then it would bring in now this issue of the outreach. You were talking about the science awareness, because currently I know within the country and Limpopo, we also have what we call a GIS week and remote sensing, where high school students are introduced. They come to the university, they go to various centers, they are made to appreciate this space data, and they are even made to appreciate how it is applied in society. So I don't know whether this is a question or it's a comment or what, but I'm really happy. So I will engage some of the physics guys, and including those who are responsible for the one science center, to see how we can expand the lab there. Thank you very much.
Thank you, Madam Murungwini. I see Dr. Mulauzi's unmuted herself. Maybe she wants to make a comment about that.
Yes, thank you, Dr. Mlele. It's not a question, but happiness in my heart. Dr. Mrongweni, thank you very much for such an offering. Vuani Science Center is not only for the scientists, it's for the whole university. And this lab for geography and what GIS can do, they are very welcomed at Vuani. I think by next week, we can also have a meeting when Dr. Maluta is back, because they are out during this National Science Week, so that we can do a special arrangement and make a progress out of what we were challenged today, so that we can engage the secondary schools, because what we were doing, engaging these secondary schools, it was based mostly on physical sciences, the physics and chemistry, and sometimes mathematics. Sometimes this geography, it was just being taught to them to revise, but we need something practical, something that they can see. The observation is very important to the learners, so that they can be attracted at least to join even our university. They see the importance of their nearest university. Thank you very much, Dr. Florence.
Thank you so much, Dr. Mlauzi. I appreciate.
Thank you, colleagues. That's very much interesting. I see no more hands. Dr. Marubini, do you have any closing comments about this whole issue?
Yes, what I can say is that there is a saying which say, if Muhammad doesn't go to the mountain, then the mountain should come to Muhammad. All I'm trying to say is some of the initiatives which might need to be taken care of, yes, they are risky, yes, they might seem impossible, but until we take a first step toward them, we won't see how possible and how far we can go. So even if, as I gave this speech and say to the whole National Science Week organizers, and say it is being said. The other thing is, when do we start to take first step toward the direction? So unless we take a first step toward the direction, it will remain difficult and it will remain unchallenged. But one step, next time you will find yourself making the second step, and that will be the paving of a trails, which will be the beginning of something in the right direction. So I am very pleased that I am invited to give a talk, and to find that at least there are people who are confirming that it was an eye-opener. I really appreciate that. It was also an eye-opener for my side, because the minute I got the topic, I was like, I do not have to speak about stars this time. So it has to take the various structures of space science. Like, for instance, we do have things in different ways. So we do have some of the things which we do in space science. Like, for instance, you will go to the doctor, you find that you are having a problem with your hand. They will have to scan your hand using the X-rays. And those X-rays are some of the product of the things which we use in space science to analyze the data on how the universe and on how the Earth, using the Earth observations. So such things are very much important. So fellows, whenever we hear the word space science, it's something which we need in our daily life. It's not something which is only useful for people who are at the observatories, and outside there, like I've mentioned here. It is something which it needs us. You cannot say where space science is not for us. Space science is what we are supposed to be doing. And by so saying, I say, I thank you. I think I've convinced all of you that space science is the way to go.
Yes, indeed you have, Dr. Marubini. Thank you so much. Before I hand over to Dr. Dinaro for the closing remarks, can I please ask from the organizers, is it by plan that we must take a 1 hour, 15 minutes break? If the answer it's a no, can't we have a 30 minutes break? Because I see our next speaker is already here amongst us from the SABC.
No, it's not 1 hour because we are having 3 sessions today. Let me verify the starting time of the next one. You can give us the break for 10 minutes. I think it's fine.
Yeah, because from what I'm seeing here, we are meant to close by 10 past, quarter past 10, and then we are meant to come back at 11:30.
Oh, no.
Yeah, no,
No, I will inform also our people that we cannot go that far. If you are giving us 10 minutes, 15 minutes, we come back 10 to 15 minutes, depending on what we are agreeing on. And then we start by 25 past or 20 past. I think it will be fine.
Yeah, let us say we start by 30:30. I think maybe you then meant 10:30. Then I think
So,
10:30, 10:30 should be fine. Colleagues, there it is. Let us break for 15 minutes and then come back at 10:30. Thank you so much.
Thank you very much. No, I didn't see that.
No, I thought as much to say no. This could be a mistake. Honestly, thank you.
Yeah, it was a mistake. Thanks very much.
Okay, all right, all accepted. Thank you.
Okay.
So, hello.
Hello.
Thank you so much for assisting me now in that regard.
Excuse me?
For the time, yeah.
Okay.
Excuse me?
Yeah.
Excuse me? Dr. Mlele?
Dr. Tina.
I'm not sure now. So I will.
I can hear you, Dr. Tinaro.
Yes. So what are you saying? Am I supposed to get in now or what?
Oh yes, please do the closing remarks and then we take a 15 minutes break. Thank you.
Okay. No, thank you very much then. No, I want to take this opportunity to thank the organizers and most importantly to thank Dr. Marubini. Dr. Marubini is our own timber from Univen, and he's shining out there, coming back to, inform us, opening our eyes to see the importance of science. And I also need to emphasize, and I wish we had our learners. I saw Mr. Kedzi was present here, and I was informed that they were in schools and they had some connections where the learners would see and listen to these talks. If it is happening now, I think it is really the best thing ever. Dr. Marubin's really showed us that the science we are talking about, we are not like talking of things which are not reachable. We are actually immersed in it. We are like, it is surrounding us. It's an ocean and we are dropped in. So we are surrounded by it. Think of all the applications he mentioned, from medicine, from agriculture, name it, energy, and so on. All those applications, we are living with them. And one would wonder why is it not, like the main universities like University of Venda. That's why I intentionally asked him to give a recommendation of what should Univen do to actually, reinforce that area, because of its so important, a role it plays in our modern world. We can see also from even the, the interactions, the comments, the questions from Dr. Murungweni, what a very, very, very relevant contribution she made. Space science, GIS, and so on, all those things are started in geography. And we have got an opportunity of actually building that capacity from grassroots, going to our schools. Like we are, one science center is doing wonders, rolling out science in the, the communities by way of, awareness raising in our schools. And geography being so linked that the maths want to say is physics, but geography, it just pulled out just for specialization, but it is the same. We are studying the same things. We are talking of the same. Wonderful from Dr. Marubini. Dr. Marubini, continue being our friend. Come to our departments whenever you have a holiday. Please don't spend it in your home. Spend it at Univen, so that you make the right influence, that we can even resuscitate the modules like astrophysics, and if we don't have many power, you have time, then please ask yourself, if it means voluntarily, just come and assist. I really see with all these, happenings in the energy area, we need information from space science to, predict or to work out what we can get from, space science in terms of energy, agriculture, and so on. So this was really a wonderful talk, and I don't doubt we have benefited quite a lot. In short, thank you very much, Dr. Marubini, for such a wonderful presentation. I thank you all.
Thank you, Dr. Dinaro. Thanks for such wonderful words. Colleagues, let us take our 15-minute break from now and come back at 10:30. Thank you.
Dinaro.
Hey, what are we?
Okay, I just want to confirm. I know we are on break. I just want to confirm that students are watching live now.
Very good. Thank you very much. Thank you very much. I thought it was by me.
Dr.
Yes.
Dinaro? Yeah, we are live. We are here.
Hello,
We can
sir.
hear you.
Yes,
we can hear you.
Listen, yeah.
Very good. Thank you. Okay. Thank you very much. And this is wonderful.
Thank you.
Thank you, colleagues. Thank you.
That was Dr. Nemangwele. That was Dr. Nemangwele. And yes, I don't know if Kedzi can also come in, but Kedzi, I talked to him now. He said Pipini Minga, they are watching live.
Yes. Okay.
That's very good.
I'm also excited. Super colleague, I'm also excited about that. Can we know roughly
very good
a rough estimate of the numbers involved?
Exactly. And I think in the next session, we will ask the chair to say, can we have a word from our coordinators from different centers, just to say we have got a crowd of, so that we really see that. Yeah, because we are seeing only 10.
In any case, even
No,
students can ask a question.
Yeah, can just make a small noise.
Yes.
Okay.
As evidence that we are there.
Exactly. Yes. Yes.
No, this is wonderful.
Kedzi, if you are hearing, if you are hearing us, will you please come in and tell us probably how many students you have in your hall?
I think Kedzi, he must have. I don't see him now. I saw him at the beginning, but now I'm not seeing him. Oh yeah, it's now there.
Yeah, I talked to him just now. Let me call him again on the phone. And so people are interested in knowing how many students you have in the hall, if you can maybe estimate, or if you took maybe a register while they were entering. Okay, thank you. I hope they were listening also. He promised to come back to us.
Colleagues, it is now 10:30, and I think we can continue with our program of the day, because I see also our next speaker, Dr. Wanda Juniper, Juniper has been here with us ever since the starting time. So we welcome especially those who have joined us along the way. Thank you so much for making time to be with us on this special day. I'm now going to hand over to Dr. Nemangwele so that he can introduce our speaker. Over to you, Dr. Nemangwele.
Morning, everyone. Hello, colleagues.
Good morning.
Can you hear me?
Doctor? Yes, we can hear you.
Good morning.
Yes. Okay, let me go ahead and then introduce one of the speakers. The guy I'm talking about is Dr. Wanda Juniper. So this guy, he started being a radio producer in one of the, and he again moved to become a radio station manager at Univen. Yes, they have done some courses at University of South Africa as a learner support facilitating officer. He has been a radio presenter for science and technology at Parapara FM for many years, starting from 2006. He had done some course in e-tutor in communication, University of South Africa. He is again being a lecturer in media studies at University of Venda. And currently now he's a senior lecturer in media studies at University of Limpopo. So let's welcome him, and we're looking forward to have a good lecture with him. Over to you, Dr. Wanda Juniper.
Thank you so much. Let me start by forgiving Dr. Mlele for mispronouncing my surname. You are forgiven for that. My surname is Juniper, not Jupiter. Anyway, I heard Dr. Tinaro saying that Dr. Enos Marubini is a timber, or it's a timber right at the University of Venda. But I also want to state it very clear that I'm also a timber at the University of Venda, for the reason that I was once a student at the University of Venda, even though I never got any qualifications from the university. It was that time long ago when there was no career guidance. Then I was doing a degree called BA Plain, where you have to choose the courses on your own. You just choose all the courses you want. As long as they're 10, they say, okay, it's okay. They make a degree. Then I had all the modules, which end by ology. I had psychology, theology, zoology, archaeology, criminology, all those modules. Then later on, I realized that here I'm going nowhere. That is then I realized that it could be better for me to deregister. Then I deregistered and I went to the University of South Africa to start another degree. Anyway, I'm here today, ladies and gentlemen, to talk about something very important. I'm so happy that people who spoke before me were very good in articulating exactly what we're here for. My topic is the importance of basic science in science communication for sustainable development. So when I go further, you'll hear that if you listen to me attentively, you will understand that I will be emphasizing the importance of science communication in basic science for sustainable development, rather than the importance of basic science, but the importance of science communication in basic science, which is more important. Let me start by giving the definition of communication. I took this definition from Fori. Fori is a well-known It's a well-known communication academic. He defines communication as a process that occurs when ideas, information, and feelings are conveyed between individuals or groups of individuals for deliberate purpose. So this simply means that when you communicate, you don't just communicate. You communicate because there's a purpose. You communicate purposefully. You communicate because you know why you're communicating. You're communicating because you want the message you're delivering to reach the people whom you want. It means that you've got a target audience who should receive that particular message. So that's why there's the words deliberate purposes. So let's come to science, basic science itself. Basic science is a very important thing. If we need the country to become developed, we need basic science. And definitely basic science should be understood by everyone, the whole public itself. So the most important question to start with is why it is so important for scientists to be able to communicate to the public. Why is it so important for them to be able to communicate to the public? Why don't we emphasize the issue of saying scientists should have the spokespersons who will communicate for them? Will it be relevant to do that? The answer is no. We need scientists to be able to communicate to the public. The reason, and the most important reason, why we need scientists to be able to communicate to the public is for the increased awareness of basic sciences, which is expected to lead to increased opportunities for new discoveries, which can improve human well-being within the framework of sustainable development. So in simple terms, it means that if all these discoveries which are done by scientists, all these research results, if they are not communicated to the public, it means that we never know why we're researching. We don't understand the importance of researching because we're not researching for other academics to read our research. We're researching because we want the whole public to benefit. So how should the whole public benefit out of the research we do, out of the discoveries we have? On many other issues, basic sciences have an important contribution to make to progress towards a sustainable world for all. They provide the essential means to address major challenges, such as universal access to food, energy, and sanitation. And they also enables us to understand the impacts of the nearly 8 billion people currently living on the planet. So that is then we begin to understand the importance of basic science itself and communication, because this science should be communicated well to the public. But one of the prerequisites for sustainable development is knowledge. This is very important. This is one of the prerequisites for sustainable development. It's knowledge. So this simply means that this knowledge should be transferred to the right audience. This knowledge should be transferred to the people who need it. Who are those people? The same public I was talking about before. Public should have this knowledge. Transferring knowledge is therefore a fundamental challenge for sustainability. In a context where external knowledge must be integrated with local knowledge in order to promote user-driven action. So the most important mistake which scientists do is to leave communication in the hands of journalists. That's a very big mistake. Scientists leave communication in the hands of journalists and say, journalists will communicate this. Let me give you a very good example. We say there is a function. that in this function, it's a big function, a scientific function, then those well-respected scientists are invited to speak there. Then after speaking, you say journalists are the people who should inform the public about it. It means that journalists should interpret the whole speeches to the public. So most of the scientists, when they speak, they don't take care of the issue of simplifying the language. So it means that role is left in the hands of journalists. And we're talking about journalists who are not even trained about science. Most of the journalists in our country know nothing about science, nothing else. So the danger is most of our science messages are misinterpreted, and the wrong information is driven to the people. A very good example, during the start of the COVID-19, there were so many mixed messages, and those messages were delivered by journalists. And I don't blame them at all, because they know nothing about science. You remember Professor Karim would have very, very intensive meetings with the committee. Then after that, they will just give that message the way it is, the message which is very scientific, and give it to the journalists, which means that journalists have to interpret that message and take into consideration that journalists know nothing about science. So they interpret it the way they want. So the more they interpret it the way they want, then it means that a good message is being lost right in the way. Then they misinterpret the message. Then people receive a wrong message. You remember one of the messages, it was so confusing, most especially in KwaZulu-Natal. It was a disaster. The president even mentioned it, that most of the male people were not conversant with the issue of taking the vaccination. The reason being that they say they were informed that if you take vaccination, as a man, you will never be active in bed. Sexually, you will be very weak. But you can't blame those people. And you can't blame journalists. We blame scientists, because they are unable to deliver the message the way it should be. They are unable to simplify the message, to simplify the content in such a way that it will be very simple to be consumed by the journalists. So that is another area which is very important for journalists, not for journalists, for scientists. They should be able to understand this, that the more they don't communicate this message in a simplified way, it misleads the public. Let him go ahead and go to the issue of the social media. So it's not just the issue of leaving everything in the hands of the journalists. Even social media. Social media is very strong these days, very strong, so powerful. And they're very quick to communicate messages. The problem is only one. Who's that person who's communicating in social media? And if you check clearly, most of the people who are able to communicate on social media are those who didn't even receive formal qualification. Those people are not educated. They are very strong on social media. So if we say people who are not educated, people who are not trained, are very strong in communicating to the public, do we trust that message which they send? The answer is no. We can't trust the message they send to the public. But we can't say these people should stop communicating messages related to science. They do, because they've got that freedom of speech. So we must also blame us again as scientists. Why don't we monopolize that space of social media? Why don't we? Because if we're able to train the public, we give them the information in a right way, definitely they will take that information and use it on social media. And we'll be happy that they are using the same message we gave them, which is very good. But we lack on that. Quality and responsibility. Don't forget, we're talking about sustainable development. There is no any sustainable development without the right communication going to the right people. People should be informed, and they should be rightly informed. That is then you see that there will be development in the country. So we need such development, but it starts here, communication. It starts here. Scientists should know exactly how to communicate and how to give quality and to be responsible enough when they go to social media. The issue of democracy and a discussion about science in society. I gave a bit of it not so long here. We're in a democratic country. Everyone's free to communicate. Everyone can say whatever they want, wherever, any space, they're free to do that. So the problem is here. They also communicate science because they're free to do that. So the question is, should anybody, regardless of their preparation, have a say on science communication? Or we should take it as one of the Italians. I respect this guy. I usually am able to pronounce his name, but he's an Italian. He once said, only those who have studied can comment because science is not democratic. No, by the way, it should be the other way around. Not only those who have studied can comment on science because science is not democratic. So what does this mean? It means that everyone can communicate science. But all these things are happening because we are folding our hands. We think everyone could understand us, and it's not true. It's not true that everyone can understand us. There's a lot of people who couldn't even understand what we say when we deliver our speeches. So we need a very simple language, but that cannot just come. People need to be trained. Another thing again, science is rarely visible on mainstream media. Science is rarely visible on mainstream media. Since I got this invitation to come and address here, I took my time to listen to different radio stations. I was just listening right on top of the hour. I was listening on top of the hour, listening to the news. I was listening to all these radio stations, these national radio stations. I'm telling you, until today, I never had any piece of science news being read on any radio stations, not even a single one. What does that mean? Because it doesn't make sense, because there are so many discoveries, so many science discoveries all over the world, all over, so many, and very important discoveries. Why are they not there? It comes back to us as scientists that we are not communicating this the way journalists should be enticed and feel that this is important news. Because most of the journalists do not even regard science as news. I was talking to someone, that was the day before yesterday. I was arguing with this person to say that, are you aware that politics was not the way it is some time back? It was not the way it is. It was meant to be the way it is now. When you wake up today, you buy a newspaper or you go to your cell phone, you check news. In your head exactly, you need to check politics. you need to check politics, not any other thing. You want to understand politics. What's happening? How about Jacob Zuma? What this and that and that? So people can be trained to be inclined to science news. That can happen. You go to Germany. Go to Germany now. Politics is not so important than science in Germany. When people read news, they talk about science. You listen to your radio, you find that 90% of news is science issues. You check a newspaper, science issues. Then I try to inquire, why is it like this? Then the answer I got is that scientists were trained in Germany to articulate science in a very simple manner, in the way that even a layman in the street could understand science very simply. So that also led to developments in Germany. That's why when we talk about science, we talk about technology. You can't rule out Germany. Of course, when you talk about any development in technology, you talk about Germany. The reason is that everyone in Germany is able to talk about science. A layman in the street in Germany knows science, but in a very simple way, because it's being communicated in a very simple manner for someone or everyone to understand. That is exactly what we lack here in our country. But it's really up to us as scientists. Let's get into the outreaches, the science outreach projects. University of Venda have got so many outreaches. As we're speaking now, Dr. Maruta is out. That is science outreach project. So the question we should ask is that when they are there, where they are today, are they understood by the public? Or they are just there to say that we had so many outreaches? Are they understood by the public? The public talks during school visits, where the most popular science communications activity for scientists are there. Do people understand when we are there, or we are just there? But I'm saying this knowing very well that Dr. Eric Maruta is very good in simplifying science. Exactly the same as Dr. Enos Marubeni. They are so good in doing that. I talked about newspapers, that it's very rare to get news simplified in newspapers. But where should it start? That is the question. Where should it start? Let everything start at home. Charity begins at home. I was also checking the newspaper called Nendira. That is the University of Venda newspaper. I think you read it. So you ask yourself the question, why is it like that? This newspaper belongs to the university. And I don't see a lot of science news on this newspaper. What is wrong here? Do we blame the newspaper itself? Do we blame the journalists who are covering stories for this newspaper? The answer is still no. We blame ourselves as scientists. Are we approaching them? Are we giving them stories the way the stories are so enticed? Are we giving them simplicity of the stories? Are we doing that? Check Univen FM, a very powerful community radio station. You listen from Monday to Friday, not anything related to science. Why? So it means the entire public which listens to Univen FM is deprived of science news, basic science. I mean, just basic science, nothing else. You will hear nothing else. You listen from Monday to Friday, nothing is like that. That thing is also happening even where I work. I think it is only my program. That is my only program, which is dedicated to science. But you check all these other programs, you hear nothing about science. So I blame scientists that they're not making science very interesting. Science should be made to be so interesting so that everyone should feel that I should engage in science. I should understand science. Some of the challenges in communicating science. There are some challenges which are there in communicating basic science. I was talking to one of the scientists saying that you are very brilliant in science. You're so good in science. You are well known all over. But what is it that makes you not to simplify all these discoveries so that it could be understood very well by everyone? So what I got is that for scientists, their time is very consumed by heavy workloads due to research. And I understand that. Scientists are very busy. They're so busy. Every time they're so busy. So that's why they ignore this part of communication, because they're so busy. And they don't believe that it's their duty to communicate. They believe that their duty is only to research, to discover new things. But communication is another thing, which is not up to them. And which is wrong, absolutely wrong. Because we cannot leave this communication to other people, because they distort the whole message. They make the whole message to be not the way it should be communicated. I remember when this guy said to me, he said, I do the grant writing. That's what he does, the grant writing. I do the research. I finish the research, and now they want me to still translate what we found out. And sometimes doctors are saying, should that still be me? Can't it be somebody else? I understand their concern, that they're tired. They're so busy. But I think the most important thing here is that they don't want to tell the truth, that we are not trained. We don't understand how to communicate in a very simple manner. They don't understand how to communicate in a simple manner. That is lack of training for basic science and communication. Another thing again, which is very important, language consideration. Language is very important. I was reading another book written by Onyani Chika. He's a Nigerian. This guy is still in America. He wrote a certain book, which I think so many people have read it. Especially, I think if you also read it. The book is called Capitalist Nigger. Capitalist Nigger. It's a very good book to read. So this is what he said. He said, when you check the way China it is today, it is because of two gentlemen, only these two gentlemen, who are Chinese. These guys were working in a military base in the United States, in the Faculty of Engineering. So these guys were able to communicate all what was happening inside that Department of Engineering in the military base. Every time when they knock off, they were able to write everything in Mandarin, a language spoken in China. And they were able to simplify that language very clearly in science and send the message back to China. Every time they were sending the messages back to China in a very simple manner, very simple language, until China start developing, because that messages which are being stolen in the United States. Now this is exactly how China is today. That is the reason why China is how it is today. And lower primary students were able to consume that message because the messages were very clear and very simple to be consumed by even those who never went to school. So this is what we're lacking here. So language is also very important. I understand English is important, but it becomes much difficult to communicate science or basic science to the public in our country, realizing that we've got people who can't read, we've got people who can't even even speak English. People who can't read and write, how do they understand us? So it means that we have a duty to communicate that messages in their languages so that they could understand us. Okay. Some of scientists say that there's limited science communication opportunities. That's what they say. They say there's a limited science communication opportunities. Most of the scientists say that lack of invitations limited to their science communication activities. Some say there's not a lot of opportunities to speak to the public. But I don't think it's true. It's not true in that way. Because you approach me today, you say, I've got this, which is very important. Dr. Ines Marubin knows very clearly. Dr. Mrauzi knows very clearly. If they come to me and say, we've got this message, which is very important. We've got this discovery, which is very important. We need this to be shared to the public. Immediately, I will tell them that let's speak on Wednesday in the afternoon, 2:30. This is very important. Let's go live on it. So when you hear scientists start complaining that there are no opportunities, there are no this and this, you don't understand. It means that they want to be approached. But instead of want to be approached, approach. Don't wait to be approached. Because we are the people who want that development. We want that science development. So we should be the people who take everything to our shoulders so that everything should go ahead smoothly. I think I spoke a lot, but I have to go to, I can't just speak like this. And after all, never give solution on what is the solution. Okay. I'm trying to peruse here so that I could check exactly. There's a solution. Solution, I think solution is only one. There's only one solution. The solution is that scientists should be trained. Scientists should be trained to communicate very well. How should this be done? My suggestion is that we should have some short courses for communication science. And that can be, it can be premised in the Department of Physics. There could be nothing wrong with that. It could be premised in the Department of Media, but it could be better if it's premised around the Department of Physics, so that it could be the one to train scientists on how to communicate science in a simple way, so that people, the whole public should understand exactly what is this, what is basic science. Because without basic science, there is no sustainable development in the country. Nothing will ever happen. So the whole of Africa is suffering from one thing: science communication. That is a disease which is really making the whole Africa suffer. And it can be cured. It can be done very simple. To assist on that. Ladies and gentlemen, I think it's better for me to wait for the questions. I think more information will be given out from me, especially when they're very important questions. I will answer all your questions. I don't want to speak longer because most of the issues I have to articulate on revolve around one thing. That's why I'm saying it's important for you to ask questions if you have. This is the end of my presentation. I think it's very short. Oh, I think Mrauzi, I see your hand. Dr. Mrauzi, I can see your hand. Dr. Kirui, I can also see your hand. I don't know who should start. Dr. Mrauzi, are you starting? I can't hear anything.
Sorry, Dr. Juniper. My apologies. I received a call from our secretary here. There was a pressing matter that I had to attend to. I gather you finished with your presentation.
Yes, exactly.
All right, thank you so much. Sorry. Dr. Mulauzi's hand has been up for quite some time, but I think it was on a different matter of which she phoned me on the side and we spoke about that. Dr. Kirui, do you have something that you want to comment about?
Yes, Chair. Thank
Please
you,
go ahead.
Dr. Mnyageni Molele. And thank you, Wanda. That was a wonderful exposition about the really serious need for communication. I'm sure all of us listened very harshly. I mean, we were so quiet because what you are saying is really a game changer. I understand it as such, no doubt about it. So you put it so clearly. And now, I wonder, how did it happen? So my first question is, have you articulated the way you have done to other platforms, especially, let's say, in government meetings, important government meetings? Of course, I appreciate that you are at the SAPC, and I am sure you're going to change things. From the way you're talking, I have no doubt in my mind that you will bring change that is required. My question is, how far have you and your colleagues who are involved in communication, in science communication, how far have you tried to make such an impact, or rather, to put forth such an idea to the government and stakeholders? Because as you have pointed very clearly, it's a very serious problem. So that is my question, sir. I noted some other questions, but in fact, one of them, you answered it already. I was saying, when you consider the serious lack of information to the general public, will we ever make any leap at all? Yeah, it's a serious matter. I had actually asked that question, but you answered it. I said, now, in South Africa, we have 11 languages. Isn't it that they are right also to know what's going on in science? I'm sure with you, you would say yes. But is there any effort being made to make it? Of course, you have also said the main problem is the scientists. They don't come. They want to be approached. So it's a serious thing, I understand. So I just want to know, to what extent as you and your colleagues tried to change things the way you are doing now. And I am happy for this wonderful program from the government in response to the international, of course, call, the UN, which is actually named this year International Year for the Basic Sciences for Sustainable Development. It's a wonderful gesture also, and initiative. So for you to speak like this, I'm glad that others are listening, like we are told, learners in schools are also listening. And your talk, of course, being recorded, I'm sure we'll share more at the department. And then hopefully, as a follow-up, you may come and assist us to get on the right path, because we are in the wrong path, definitely. So my questions are, again, have you and your colleagues tried to change things by saying what you told us today? Because it's breathtaking. to say the truth. It is going to change everything if only it can be implemented. Thank you so much.
Thank you. Thank you so much, Doctor. I remember I engaged the Department of Science and Innovation. I'm very close to that department. My relationship with that department is very good. There's this guy called Ribuani Masebe. He was here yesterday. He was with us here online yesterday, but I can't see him today. We engaged a lot. Then the Department of Science and Innovation is prepared to sponsor a program called Science Communication, where, of course, scientists should be trained on how to communicate better. Then my proposal to the department was that not only scientists should be trained, journalists should also be trained, because those are people who should know exactly how to interview those artists. So they should also be trained to understand clearly science, while scientists should be trained to understand communication on the other hand. I think everything is around the pipeline. I remember last year they were saying that program should be premised the Department of Science at the University of Limpopo. But things are just dragging. I don't understand what's happening. But I think later on things will be okay. But it was my wish that it also happens at the University of Venda, because I love the university. Probably maybe because I'm Venda. So I would love it to happen at the University of Venda, to have such courses, because they are very important. I think I've answered your question, Doctor.
Yes, thank you, Wanda. In fact, when you talk like this, hey, what happened? Yes, Wanda, when you talk like this, it gives me a lot of courage, because personally, I am inclined into languages. And then I was wondering, how will people catch up? How will people catch up if they are not given a share of this? So even though you say that there was an intention to set it up at the University of Limpopo, it is something so important that it can happen anyway. It can happen there. It can also it should also happen at the University of Venda. So I am sure if you can engage Dr. Maluda, I would really be happy if you talk to Dr. Maluda. Then you will reach out to us, and we can see how, together with other colleagues, of course, Dr. Molele, Mnyakeni Molele, the HOD of chemistry, and all of science, in fact, and all of science, we can talk together and see how that can be done now rather than later. And in fact, for your information, yesterday on the first day of the National Science Week webinar here, the first speech was by Professor Madala, and he gave a wonderful speech also. To me, he is one of the best science communicators that I know around. So it is heartening, it is encouraging that we have people like that. People like Professor Pesong also, they communicate issues of health and science as a microbiologist. Professor Madala as a biochemist, they can those are just examples, but we have pockets of those which should be encouraged, and then to reach out, because you see, yesterday in the evening, I actually called Professor Madala, and he said, I visit schools and talk. Then I was encouraged. But I am happy that you from SAPC is coming to tell us that, and encouraging us to say, no, don't wait until you are invited. Invite yourself. Like Dr. Marupini also has articulated very well. So you see, we have people who can communicate, and it will take just a little encouragement for others to spring up and communicate science. So the problem is lack of knowledge as to the importance of this. of course, you have articulated very well where the problem is. And I am sure with your encouragement and collaboration, we can chart a new path in this very important issue. Thank you so much.
I'm not so sure if there's any other question.
Yes, I see there's a hand from Mr. Tando Kedzi. Please go ahead.
Thank you, Chair. Thank you for your presentation, Dr. Wanda. I wanted to ask something, but since I have, I think, 4 learners, so I think I will give learners a question, time to give you some questions. You may introduce your name, then go ahead.
Okay, thank you for the time. I would like to greet each and everyone in this meeting. The one speaking now is Masana, and my surname is Nkondo. I'm situated at Pipitongwane, which is situated in Grand Farm. I wanted to ask, according to what you were saying, when you said that, do you mean that scientists tend to be in the background and let their work get manipulated by people who want to push their agenda? So, like, is it even possible for scientists to take up leadership positions where they will be able to voice their contributions out, and us as people get to hear the information from the source? So I would also like to ask about when you said the scientists should be trained. So, like, are the courses going to be expensive, or maybe they are going to be affordable for anyone?
I'm not so sure if I should answer this one, or should I wait for all the questions?
No. I prefer you answer them one by one so that there's no confusion. Please go ahead and answer this one.
Okay. The answer is exactly no. The issue of manipulation, it doesn't mean that when scientists are not on the forefront, the message will be manipulated. It's not the issue of manipulation. The message is losing the meaning, is losing that meaning because people who are communicating that message are not trained to communicate the message. They never know. They're not doing that intentionally. It doesn't mean that journalists are doing that intentionally. No, it's not the intention to communicate wrongly. In their own, they feel that they're communicating message correctly, the way it should be. But when you are a scientist, you feel that no, my message here has been diluted. It's not the way it should be. So that's the reason. The issue of saying, I didn't hear him very clearly, but I think he was saying, am I saying scientists should be given the chance probably to be the presenters, probably on the radio to be the presenter to present the message? No, it can't be on that way, not on that way, because presenters do not give information. They only ask. We're trained to pose those questions which trigger good answers. So it means that scientists should remain scientists, but trained how they should give that message in a very simple manner, simple way, which should be understood by everyone else, should be understood by the whole public. That is how it should be. I think I answered your question, Masana.
Yeah, but what about the last one about scientists should be trained?
The issue of the cost.
Yeah.
I'm not so sure. Probably the university is the one who should answer that one, because it depends on the universities. I don't know how those courses should cost to an individual. I'm not so sure about that, because it also depends on whether it will be short course or be offered as a degree or something like that. It depends on that, but I'm not so sure on that.
Okay, if you may please answer my one last question before I go.
Yes.
If you recall, you talked about monopolizing. I think
exactly.
You said monopolizing social. What did you mean about that?
That simply means that the space which people use on social media, it should be Twitter, it should be Facebook, all these social media, platforms. If you check all these people whom I said, they are not well educated, but they're very strong and very active on social media. Those are people who put so many messages every time. So it means that they are monopolizing that space. They are taking that space as their space. They are owning the space. So if scientists try to monopolize, to own that space, so every time you get into the space, you see science message. Every time you get it, you see only science message. It means that you're monopolizing that space, and which is very good for the public to understand the science messages. Did I answer your question?
Thank you.
Okay.
Thank you very much, Mr. Kedzi. Dr. Mulauzi, do you have a question?
Sorry, I still have two more. 2 to 3.
Who's this now?
My name is Gift and my surname is Chawogan. I'm a learner from Pipishongwani. So my question is, as you have said that people who are dominating on social media or posting on social media are mostly people who are not educated according to science. Why doesn't the government employ people who are educated or people who know science to take care of interpreting the scientists' researches?
Okay, thank you. Thank you so much. I understand your question very clearly. It is very simple for the government to do that. The government can do that, to hire people who will interpret the messages. But that is exactly what I'm discouraging. That is not a proper way. That is not the way it should be done. We need everyone to consume the message the way it is. The more we start interpreting the message to the people, in any interpretation, there is a loss of message on the way. There is a dilution of the message on the way. So people should get the message exactly from the horse mouth. So these people should be trained. These people should be given the message the way it is. So that's why we say scientists should be trained to make those messages very simple, to make science so simple, to communicate it in a very, very simple way, so that each and every individual could consume that messages with no difficulties. So the way of hiring people to interpret this and that, I think it will never assist us at all. So if we do that, we are also denying an opportunity to the public to be more conversant with science itself, because it means that now they must fold their hands, knowing that now the other people will do that. And scientists, again, will never communicate direct to the public. So these are people who should communicate direct to the public. So if you hire people to interpret, these people who will interpret will never be scientists, definitely. These are people who will be hired who have got qualifications for interpretation. So I will show that they will interpret correctly. I don't believe that. So that is exactly what I would discouraging. Did I answer your question? If not, please tell me.
You did answer my question. So I have another one.
Okay.
If I can recall, I remember you saying that China and Germany are well developed because everyone in Germany do understand science.
Yes, exactly.
So my question is, if a lot of people can understand science here in South Africa, will South Africa be developed?
It's not only the issue of understanding. It's the issue of understanding. When you understand, it means that you are able to engage with science. So it becomes very simple for you to innovate any other thing science related, because you understand science. So innovations become so simple for those people who understand science, basic science. So because you know nothing about science, you know nothing about basic science, you can't innovate anything else. That's why if you go to Germany now, you will see that there's so many innovations, technological wise. That's why we talk about Mercedes-Benz, we talk about Audi cars, we become so proud of them. But they have been innovated by people like you, not so It's not scientists who innovated such things. Members of the public, people who consume that messages, and then go to those who know science. So there should be a thorough engagement because people know science. So communication itself to the people doesn't make the country to be developed, but it enhances the engagement, science engagement. So that engagement is needed. That is the reason why today, when we're sitting here, you see that we're so few here. You can count how many we are. We're so few. But if you check people who were invited, so many people have been invited to attend this meeting. The reason is only one, that they don't feel the importance of it because they've never been trained to understand science. They don't think it's important to be here. They don't feel it to be interesting. So people should be, something should be instilled to people to feel that science is very interesting. That is exactly what happens Germany and China. They feel science so interesting. Did I answer your question?
Yeah, you did.
Thank you.
So I have another one, I think.
Yes, you're so free to do that.
I remember you saying that science will be interesting and enjoyable so that people can enjoy it.
Yes.
So I want to ask,
yes.
This will be mostly based on the misinterpretation of the research of scientists by journalists.
Mm.
I remember you saying that we need to train the public by giving them accurate information, right?
Yes.
So how will this help if we have a lot of people here in South Africa which are not educated or are not actually used to this industry of science?
Okay, we don't train the public. We train the scientists to communicate science messages in a simple way. It's the other way around. Not training the public, but training the scientists to communicate in a simple way.
Okay.
Are you okay?
Yeah.
Do you understand now?
Yeah, thanks.
Thank you so very much. Dr. Kirui, I see your hand is still up. Do you still have a question?
Oh, okay. Yeah, I could also comment to say what you are saying actually is revolutionary. And I hope all of us here, including you, Chair, we could think about that. It makes a lot of sense to pursue that. It makes a lot of sense to pursue that. That is my comment. And so simple things like in our own heritage as Africans, there are some proverbs which speak to some science, which can be interpreted even to people and say, no, they knew our science. We can also interpret the sciences that are in our, in our heritage itself. I remember what comes to mind now actually is some proverb in Fenda, which says, is it a proverb or that's what I'm saying? It says, auna uima ndi uwa, is to say we cannot stop on anything. Like if you are walking, you cannot stop. Auna uima ndi uwa. And then actually there is a relationship between that statement and everything else. Like even the stars that Dr. Marupini was talking about, they are all moving because of course, science, mechanics. Nothing stops. So if they stop, they fall. Everything is in motion. So even such things, we should make sure that people understand science, that our people knew science and relate to the modern science itself. No, thank you so much.
Thank you, Dr. Kirui. Mr. Kedzi, I see your hand is still up.
Yes, with two learners.
Oh, okay, please go ahead.
Okay, my name is Shalati. My surname is Dembe from Computational High School during grade 11. My question is, do you think that people who are underprivileged, such as rural areas and public schools, are highly the ones who lack knowledge about what science really is?
The question is no. This issue affects everyone. It affects everyone. Even those people who are in private schools, those who are in those schools which think that they're very good schools, they still lack knowledge. They lack science knowledge. They need basic science knowledge. So it affects everyone, by the way, not only a segment of people. It affects everyone. It's only that people couldn't see. Some people don't think, they don't believe that they lack that knowledge until it's being revealed to them that they lack knowledge. That is then they start realizing that, oh, yeah, I lack knowledge here and there. So it affects everyone. Are you answered?
Okay, one more last question. I heard you say when a new disease occurs, bad rumors are spread out about scientists. So how can we prevent this?
I didn't hear clearly. Your question again?
Okay, I heard you say when a new disease occurs, bad rumors are spread out about scientists. So my question is, how can we prevent this?
I'm failing to grab that. Chairperson, can you interpret that question to me clearly? I have got a network problem, maybe.
Yeah, if I got you clearly there, Madam, you are asking from what was mentioned here by Dr. Juniper that when diseases are cured, I'm not too sure if you say bad things or rumors are being spread about scientists, or am I not hearing you correctly?
Yeah, you heard it correct.
Yes. So and then and then she asked, how can this be prevented?
Yes.
Okay. The issue is the same issue. Everything comes to one thing. The answer is only one: training, training, and training. Training, training, and training. If scientists are trained to give information in a very simple way, when that information goes to the public, then it will never mislead the public. It will never be misinterpreted because it's well understood. Because what happens is that when the message is going to the public and the public doesn't understand that message clearly, the public doesn't go back to say, we don't understand that message clearly. What they do, they interpret the message the way they want. That's where the problem is. They start interpreting the message the way they want. And they circulate the message around the public the way they want. That's exactly what happened during the start of the COVID-19. It means that the public didn't understand clearly the messages from the scientists because it was too much scientific. So because they can't go back to the scientists to understand clarity, they should go on communicating. And they communicate it the way they understand it, which is absolutely wrong. So that's a problem. So the answer is training, training, and training. And training to who? To the scientists, so that they give very simple scientific messages to the public. Are you answered?
Okay, thanks. I'm answered.
Last one.
Yes, go ahead.
Greet you all. My name is Nzakisima Kondo and I'm from PP Shongwane High School. I heard you saying that we need to make science interesting. So I wanted to ask, how can we make the science interesting?
It's very simple to make science interesting. I think Dr. Marubini articulated it very clear that when you want science to be very interesting, you do some demonstrations, very simple demonstrations to the recipients of the messages. If you demonstrate things in a very simple manner, people start liking science. This is what happens when I usually have programs on radio with Dr. Enos Marubeni. When he comes to the studio, he will try to give those examples which relate to the public. Everything. I remember one time he was talking about a certain star. And definitely, we don't have that star in science in that way. But he was able to say there's a certain name, Masase, something like Masase. It's a certain star which is known in Venda called Masase. So the more he says Masase, you will see so many people calling in because they know that Masase. So when they hear that, they really realize that, oh, it also affects us. We know this. If he's talking about Masase, it means that it's something we know. So they want to know deeper and deeper and deeper. So that is how you make science interesting. Don't talk about something in the laboratory. Don't talk much about laboratory because these people never know laboratory. They've never been in the laboratory. Then you give examples of laboratory only. They feel bored simply. But take something very simple, something they could understand. Very simple. That is how to make science very interesting. Is your question answered?
Yes, I'm answered.
Thank you. Mr. Kezi, do you still have some more? Mr. Kezi?
I think I'm sorted now.
Thank you so very much for giving the learners an opportunity over there, and thank you so very much to Dr. Juniper. Really, your answers are in depth, and it shows you very much knowledgeable and passionate about what you are doing. Indeed, as Dr. Girui said, really, if we could take this up and try, because as you are saying, people will understand something that is very, very closer to them and popular to them. And I'm very much liking the example of the star that you are giving. That, you know, when people start to hear on radio being spoken by scientists of something that is they know very, very well, and yeah, the interest it's aroused. And indeed, that's what we want to do as scientists. Let people have interest in what we do, and we should try and really simplify our language. I believe at some point we have to be forgiven because we do understand each other when we talk, and then in the process, perhaps failing to know that any other person out there does not understand what we are saying. I saw there was a hand from Dr. Murungwini. Are you now feeling that you are comfortable and answered?
My apology. Is my hand up?
I thought I saw it going up and down again quickly, but if you are covered, then
okay. I'm covered. No, thank you.
It's all right. It's all right.
Dr. Mlele, it was my hand, and I just lowered it, but I only wanted to add on what is happening at PP Tlongwane. From the discussion I had with them, they have 202 students that they are hosting at the moment. The place is Green Farm, under Malamlele area. Thank you.
Thank you so much for sharing that information. And indeed, the learners they sound very knowledgeable, and they do listen attentively to the presenters. Thank you so much. There is a hand by I'm going to struggle with this name, Kasinathan Kaviarasu.
Yes.
Forgiveness, please forgive me for mispronouncing. Please go ahead.
No, thank you, Program Director. Thank you, Speaker. Under Juniper, for your informative presentation. My name is Kaviyarsu. My surname is Kasinathan. I'm working as a senior scientist in terms of nanoscience and nanotechnology. In the question and answer session, you mentioned do not train public instead of need to train scientists. I don't know in what form scientists need to train. Scientists, we are doing science in terms of national laboratories at the college level. You mentioned in another direction, German and China peoples, it's what are they there. Even in South Africa, we are less than 4,000 scientists in our country. Even much more scientists in Germany from the EMER company. Because those countries, China, Germany, they are promoting the science from school onwards, primary and secondary level. So we no need to train the scientist. We need to train our people from school level. We need to upgrade our science curriculum. As a scientist, we are writing our blogs and then the new invention and discoveries from. There is a different science platforms, ResearchGate, LinkedIn, even Twitter, even the different open science magazines. From the Aitamba Labs, from NRF, we are also engaging in public science lecturer schools. But who are come forward from to understand, even we are posting the blogs and videos. People not ready to come to forward to interest to watch what we are doing in our national laboratory from Aitamba Labs or reputed universities in South Africa. I hope no need to scientists, we need to brand our products in terms of science and collaboration work. So no need to science to train. We need to train our school students. We need to train our basic curriculum. I don't know, as a scientist, we are engaging in different science, various disciplines. We are promoting our science through different platforms. Even the research organizations also now promoting through social media. But our people are not ready to come forward to read the blogs. So in terms of the scientist, we are also engaging science in the laboratory in simple manner. It's not easy to say to the simple manner. To reach the simple manner, the students, community, we need to train from school level. We are also engaging what we are saying. We are producing the newspaper communications, printed media, of printed medias, and then we are communicating through all the social medias. We are also engaging to exploring our science, what's our invention in our national laboratory in South Africa. Apart from that, what we need to train as a scientist, what you advise me? Thank you, sir.
Thank you. Thank you. Thank you so much. I agree with you in one instance where you're saying students should be trained from school while they're still young. That is a very good approach. I understand that, and I really concur with you. But the issue of saying there's no need to train scientists, that is where we differ. Because the more you say scientists never need to be trained, it comes back to what I was saying, that the mainstream media is rejecting your messages. It's ignoring your messages because they don't even understand your messages. Because journalists are not trained in science. So the more they don't understand your messages, it becomes pretty hard for them to publish such a message, for them to broadcast such messages. So that's why it's very important for scientists to be trained on how to communicate science in a very simple manner. I heard you saying that science cannot be communicated in a simple way. I beg to differ with you. I beg to differ. I once hosted Professor Marara for a number of times, Professor Moronga for a number of times, Dr. Enos Marubini a number of times, Professor Madara, I even hosted him a number of times, Dr. Marutha, all these guys, they will give science in a very, very simple way. We interview them on radio. They will participate in giving science, very, very fantastic science, but in a very simple way, simplified. And that is then I realized that my listeners like science because they will get in numbers, phoning in numbers, saying that it was so interesting. I never knew that it happens in this way. I never knew astronomy. Today I understand what astronomy is because it was given to them in a very simple way. So I still emphasize that scientists need to be trained. They need training. If you're not trained, you're going to sit down with all the knowledge you have. And that bounds back to selfish. You've got more knowledge, but you can't communicate that knowledge to the public. because public cannot even understand what you're saying. That's what I'm saying. I'm not so sure if I'm so clear on that. I'm done.
Thank you. Thank you. I can feel the passion. If you say, yeah, yes, I'm done. Yeah, thank you. There's also a hand from Emmanuel Manata. Please go ahead.
Morning, guys. Sorry, I joined this meeting. I just saw on K's WhatsApp, but then I kind of saw that it was gonna be very much helpful to also give an idea in terms of what how science things works. Unfortunately, I'm not really a science person, but I'm a data science person. Unfortunately, so I am much focused on the data side, right? So in most cases, you find that students always have this question where now they ask themselves, like, what kind of career I need to choose, and what kind of issues that I'm supposed to tackle in terms of what I've seen in the world. So which means it also requires students to be out in the world to see what kind of issues are there, and then what kind of issues they really want to fix, and then based on that, and then that's when they can decide what they really want to be in the near future. And then so coming back to science part, we check mostly in terms of what it may be someone want to focus too much on maybe solving maybe some certain diseases wherein you happen to choose maybe to focus on maybe on a certain disease, then you go and focus on what on a certain field in terms of what science which focuses on that specific disease. Unfortunately, just for students who are listening to this, it also needs you to know the theory part of literally everything, to know basics in terms of how science works before you focus on something. Same applies with doctors, for an example. We have so many doctors. Usually, when you need to be a doctor who need to focus maybe on ear or maybe just on my stomach, or for an example, then you need to learn to be a basic doctor who need to be able to fix any kind of disease that anyone can have. You see, and then that's when you choose to say, now I want to focus on this. I did computer science at University of Venda, and it was really great. I used to attend this science weeks with Tando the time I was still there. I know there's a lot of issues with students having to accumulate a lot of information, at this time, because you also find that the time they have in order for them to get some answers, it's quite short. But then, unfortunately, if they can get access to say, if you need more information on this, at least contact this person to have someone to contact. Because I know there's so many students who are very intelligent and they really want to know more information about what they can be. And then, yeah, so by all that, I just want to finish by saying that it's quite easy when you know what you want, and then when you have seen which issues are there out there, and then which issues that one need to solve, and then which kind of degree you need in order for you to achieve such thing. So yeah, thanks.
Yes, thank you, Mr. Manata. Thank you, everyone. I think at this point we can simply take a break for about 50 minutes again, and then we shall come back then at 12 o'clock to continue with our last session of the day. Thank you so much. Okay, good afternoon, everyone. It is now 12 o'clock, and I see our presenter of the session, Professor Mapangwa. It's amongst us. I believe we can go ahead and start. Dr. Mulauzi, we can go ahead and start, ne? All right. Yeah, yes, sir. Please go ahead. You are now muted.
Yeah, I've just said you can now go ahead and start.
Thank you so much, sir. Thank you so very much. We welcome you again to this last session of the day, and then it has been interesting all day long, and we do believe that it's going to continue to be as interesting as we are about to listen to Professor Mapangwa from the CSIR, but all those are supposed to be done by Mr. El Putu. I now welcome Mr. Putu to introduce our speaker. Mr. Putu, are you there? I'm checking the people who are in attendance to look for Mr. Putu, but I do not see Mr. Putu. Who then can please go ahead and introduce our speaker, Mr. Ravengani? Do you have somebody to replace Mr. Putu?
At the moment, I do not have another one. Let me quickly get Dr. Mraudzi.
Please, thank you.
Okay. Dr. Mlele?
Yes, sir.
He just had a communication breakdown with Woputu, but he is joining through Kedzi, Tando Kedzi.
All right.
They are together where they are at the moment.
Okay. Is he ready to talk through Mr. Kedzi? Mr. Putu, are you ready to talk via Mr. Kedzi? Maybe let's give him some few minutes as he tries to organize himself. I see Professor Mapangwa is ready. She's sharing the video already with us. We want to introduce you properly, Professor. So as we await somebody who has been given that task to do so.
That's fine. That's fine.
Thank you. Thank you.
Good afternoon. Can you guys hear me?
Yes, we can hear you. I take it is Mr. Putu. Hello?
Hello, can you hear me?
I can hear you. Are you Mr. Putu?
All right, there was a problem with the audio. Sorry for that. Okay, thank you, Dr. Mulele, for giving me this opportunity to introduce the next speaker. So the next speaker is not strange to me. So I've known her for, I think, for more than 5 years now. She's my PhD supervisor. So that is Professor R. Mapanga. So Prof. Mapanga, she's a principal researcher and a group leader for the next generation enterprises and institutions cluster at CSIR. And before she went to CSIR, she was an associate professor at the University of Limpopo, and that is where she obtained her PhD before she was an associate professor. So her research focus is on computational simulations to study materials and also come up with new materials that can be used in energy storage. So she is a member of the South African Institute of Physics and also a member of National Institute for Theoretical and Computational Science. So she has participated in various young scientist activities or programs such as the World Economic Forum, Young Scientist, and BRICS Young Scientist Forum. She's involved also in other outreach activities to encourage the youth and also women to be involved in science. She has received distinguished awards for her outstanding contribution in science, engineering, and technology in South Africa. So we feel very honored, Prof. Mapanga, to have you as a guest speaker today. And I'm pretty sure that we are going to learn a lot, and it will also broaden the understanding of the learners. You can, if you have the slides, I think you can share your slides. Thank you.
Okay, thanks so much, Utu, for a kind introduction. So let me prepare my slides and share them. Before I go into my presentation, can everybody see my slide?
Yes, we can. Please go ahead.
We can.
Okay, I'll try to present with my video on for now. I'm hoping that I will manage with the bandwidth. If there are challenges, I might have to switch off the video and just show the slides or talk to the slides without showing my face. And firstly, I would like to thank the University of Venda for inviting me and giving me an opportunity to come and share these few thoughts on basic sciences for sustainable development, focusing mainly on computational physics. So the institution is more like my home. I think I belong to Univen. There are a lot of activities that we do with colleagues in the Department of Physics, and that is really appreciated. The collaboration that we have, it has been going on over the years, and I will show some examples on some of the work that we did together at the end of my presentation. However, I'm just hoping that, because I understand that there are school learners in the audience and as well as teachers, so I'm hoping that by the end of this presentation, particularly the learners will have an understanding or an idea of what is computational physics. And this is the outline of my presentation, where I'll start by trying to define or explain what sustainable development is, how relevant it is, and how important it is to our well-being as human beings. And I'll move to the basic sciences. What are the basic sciences and what is their role in sustainable development? Then I'll focus specifically on computational physics, trying to briefly explain what it is, then move on to the opportunities that are available when someone decides to become a computational physicist. And as I said, I'll show some examples on the research work that we did in collaboration with the University of Venda, and I'll make some few remarks at the end. And some of you might ask, why are we here? Why are we talking a lot about these basic sciences? What is the fuss about them? So the reason that we are all here today is because UNESCO declared 2022 as an International Year of Basic Sciences for Sustainable Development. And attached to this slide is the declaration that was made. I think that it was sometime the declaration was, or the recommendation was made in 2019. Then late in 2020, the declaration was made. So we are in fact celebrating the basic sciences for sustainable development, mainly because the UNESCO declared 2022 as an International Year of Basic Sciences. And those who have been living for some years, they might remember some of the international years in the past. So the one that I vividly remember is the 2005, which was declared as the International Year of Physics, where several activities around physics were celebrated, and also the one for 2011 on the International Year of Chemistry. I remember that one. So in brief, this UNESCO body, they sometimes declare they declare certain years and celebrate a certain theme for that particular year. And hence our discussion here in 2022 around the role that the basic sciences play in sustainable development. And I'll try to link the two. What is the link between these basic sciences and the sustainable development? And I believe most of us are aware of the so-called Sustainable Development Goals, which they've also been declared by UNESCO some years ago. So this is the plan that the world should or these are the goals that the world should strive to achieve by 2030, I think, according to the declaration. So there are 17 of those, and among those, there are those that are directly linked to scientific advances that are brought by basic sciences. For example, the Sustainable Development Goal number 3, which talks about health and well-being. And we know that most of the scientific developments and technologies that are in health, they will come from biology, or a combination of biology and other sciences, your physics, your chemistry, your physiology, and many others. And the second one on SDG number 6, which is on clean water and sanitation, again, you can easily link that with the basic sciences. Those who are doing chemistry, there's a lot of research in chemistry where they're trying to come up with ways of making sure that everybody in the world has clean water and sanitation. Then there's SDG number 7 on affordable and clean energy, where different researchers are applying the basic knowledge of basic sciences to come up with affordable and clean, as well as renewable energy. And in the presentation, that's where I'll focus on the example of the research that we do. And also SDG 13 on climate change, there are lots of activities that are linked to basic sciences. Then 14 and 15 as well, that have to do with life below water and on land. So all in all, we can see that these basic sciences, they are tools, or they provide tools for sustainable development. If it wasn't for the basic sciences, most of the technological developments will not be available today. And but then the question that one could ask is that what is sustainability? And it is derived mainly from the word sustain, which is to support for a prolonged period or to keep an effort going continuously. So when somebody is trying to sustain something, it should be something that will continue to happen for a longer time. And with reference to development in general, sustainability refers to keeping the productivity and wealth of our society going continuously into the distant future. And most importantly, we should do that without harming our environment, and also making sure that we do not deplete all the resources such that those that will come 100, 200 years after us, they will not find anything to keep going. So sustainable development can be defined as the development that meets the needs of the present generation without compromising the ability of future generations to meet their societal needs. And that is the definition that was coined by Brutal Report in 1987 under the document called Our Common Future. And on the right-hand side there, I just wanted to highlight that this sustainable development rests on three legs. It is mainly driven by human beings, the environment, and the development. And if you think of these three terms, it should come to your mind that yes, it is us, the human being, who are trying to come up with these technological developments or trying to use these resources from the environment to improve the quality of our life. And the critical thing there is that out of all those three legs, we should make sure that we don't compromise the well-being of the future generations, as well as our well-being currently. What do? It shouldn't hurt the next person or the environment, whatever development that we do. Then there are different approaches that were proposed for this sustainable development. And there are also, again, three pillars that are mainly talk about in sustainable development. We want to have a sustainable economy which is characterized by development decisions, policies, and practices that do not exhaust the natural resources and respect the society's cultural practices. So the economic activities that we do, they must comply to the definition here, such that it does not hurt the natural resources while respecting our cultural practices. And the other terminology is on sustainable society, which is characterized by living in harmony with nature and within itself. And lastly, sustainable environment, which is mainly characterized by natural resources being able to sustain life, health, and acceptable progress, and to renew themselves. So in terms of the environment, the resources that we use, they should be in such a way that in future they will be able to renew themselves. For example, the renewable energy that comes from the sun. So if we harvest or if we use that energy instead of the conventional ones that were mainly generated from coal, then that was in a way harming the environment, because that coal, it is not necessarily regenerated once it is mined. So the critical thing about this three keywords here is that we need to recognize the needs for everyone without compromising the needs for the next person. And there are different approaches that were proposed. For example, we need to combat poverty and deal with the social exclusion. We need to respect environmental limits. We need to look at ways of minimizing the waste that we generate. We need to have shared global responsibilities. We need to be concerned more about people, that is being people-centered, and we also need to be aware of conserving the resources that we have. And the highlight here is that all those approaches, they use scientific knowledge and technological innovations to resolve the challenge, or to keep to sustain the development. And moving into basic sciences, so a quick search from online, when you search basic sciences, these are the main branches of basic sciences. You have your physical sciences, you've got your life sciences, you've got your earth sciences, and the different subjects under each of those sciences. So under physical sciences, we've got our chemistry and physics. Then under life sciences, we've got biology, botany, and zoology. Then on earth sciences, we've got geology and meteorology. So these are what are called basic sciences. And one thing that I wanted to highlight here is that physics is called a fundamental science because all of these branches of natural science, they are constrained by laws of physics. So most of the research that is done in all these different fields, they are constrained by laws of physics. And moving forward, I want to highlight some of the technological areas where the role of science play a major role, where basic sciences play major role for sustainable economy. And you can looking at the list that I have here, it's not an exhaustive list, but it covers most of the technological areas that are responsible for our economy, or that are responsible for us to have a sustainable economy. We've got a mining, agriculture, manufacturing, IT, energy, health sciences, biotechnology, and minerals. So all these technological areas, they are derived, or the technologies that are coming from these different fields, they are based on the basic sciences, meaning that these basic sciences, they support vital applied sciences, engineering, and technology. And again, linking the basic sciences to sustainable economy, we can see some of the areas that I showed in the previous slide, but now being more specific, selecting some examples. We've got a solar and wind renewable energy that is coming from the overall area on energy. Then we've got upstream oil and gas, and many others, the aerospace and defense. So all these technological areas, there's a role that basic sciences play for us to be able to come up with different technologies. And the areas that are listed here, they have been identified by our government as the muscles of the industrial muscles of South African economy, meaning that the South African economy is derived from these different technological areas, which are mainly derived from basic sciences. And I think I also wanted to highlight that it is a great thing that the South African government strategies and focus areas are supporting these basic sciences, hence the celebration of the National Science Week this year being focused on basic sciences for sustainable development. So what I'm trying to say is that, especially to the school learners, is that if you decide to follow any of the basic sciences, don't be discouraged, because all these technological areas, they are derived from basic sciences. It means that if you are maybe a physicist or a chemist, you will be playing a big role in making sure that we have a sustainable economy as the country and as the world at large. Then here I just wanted to highlight some of the examples that or indicating the role of basic science in our everyday lives. So we have seen several technological developments that, as I said, they are derived from the basic sciences. All the vaccinations that we have had since the time of science, and recently the one for COVID-19, the technologies are based on the basic sciences. And how are these technologies improving our lives? We know that this vaccination, for example, they strengthen and develop. They they are developed via the identification of the viral origin of many diseases, and that will be the basis of your biological sciences or life sciences. And another example is on HIV and AIDS treatments, and that has significantly extended. That has we have seen the treatments significantly extending the lives of those infected, and the treatments are based or are derived from your basic sciences, like your understanding your chemistry and biology, moving into pharmacy and other fields. Then we've got the GPS that were used for directions today, and that were possible because of the work that was done by Einstein many years ago on the Einstein theory of general relativity, as well as the work from quantum physics. Then in terms of the cell phones that we use, they are made up of different materials, and the research that we do in material science enable the invention and miniaturization of the transistor for cell phones. And the one that is more interesting is the web, which is our WWW. It was invented at CERN from the need for global collaboration, and we know that most of the researchers at CERN are physicists, so they are interested in their background is mainly from physics, and this is what has happened from the past up to today. And where do we think we will be in future? And I believe everybody is aware that there is a drive for Industry 4.0, which is also called Fourth Industrial Revolution, which is focused mainly on applying these technologies to come up with new innovations. We've got big data and analytics, which mainly has to do with using the data that we've been generating over the years, either through the experiments or other methods of research, and analyze those data to make decisions quicker. Then we've got areas such as cloud computing, where the computing resources are shared globally, or everybody has got access to that, where the computing resources can be accessed globally. Then we've got cyber security, we've got robotics, augmented reality, additive manufacturing, simulation, Internet of Things. So these are the different fourth industrial revolution technological areas, and this is what is expected to change the future. And using artificial intelligence, I believe in future we will be able to find against non-communicable diseases. We will have better ways of producing and storing renewable energy. We will have ways of sequencing DNA in better ways. We will also reduce the pollution, which is a major concern for our environment, and we'll also have many new materials with the new properties or functional properties. And now moving closer to home, which is I think I've tried to show the overview of different basic sciences, but now I just want to move to physics as a subject and focus on its role in sustainable development. And I'm sure those who study physics, they know that it's about understanding how the universe behaves, and it's one of the natural sciences. It studies the matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. So this simply the definition of physics. And as I alluded previously, that it is the fundamental science, because all the natural sciences, they are constrained by the laws of physics. And there are different branches of physics, ranging from biophysics, nuclear physics, astrophysics, thermodynamics, modern physics, and many others. And I'm sure we'll all agree that we are aware of the many discoveries that have been made through physics. I don't need to mention them. We are aware of many Nobel Prizes that have been won because of the work, the fundamental work in physics. And also there are so many innovations that were made from these different branches of physics. And the fundamental knowledge that is derived from physics, it has been applied in the other sciences. So all in all, I think we can all agree that physics plays a major role in sustainable development in many ways. And every time when I look around, all the things that are surrounding us, they somehow have physics in them. Any other thing that you can think of. So when you go out, we will get into the car. I think the idea or the fundamental knowledge of developing that car, it came from the knowledge of physics. And when you get home, you cook, you do any other thing. So all those, they are coming from the branches of physics, and that's the role that physics play. That physics play for in the sustainable development. However, there might be things that are there that are not necessarily responding to sustainability, hence continuous technological developments to improve those things that might not be working, and also to come up with new things that might work better. And moving to computational physics, so some of us may know that there are two categories of physics, or there were two categories of physics when science started million years ago. So we had this, it started mainly with the experimental physics, then later there was a development in theoretical physics, where some scientists came up with the theories. And the two areas, or the two categories of physics, they've been around for so many years. However, in the past 4 decades, we had the so-called computational physics emerging as a third discipline, which can perhaps be placed between the two. Because computational physics, or in computational physics, what happens is that we take our experimental information and the theories that have been derived by various scientists, and develop models that we use computers to run, and we do research on those. We can do simulations from those models as well. And using with the increasing computing power, many problems that were not be able to solve today to be solved today, they can be solved because of the increasing computing power. So in simple terms, computational physics it's a category of physics that combines experimental physics and theoretical physics, as well as computers to model different scenarios. And what are the opportunities that one can have when he or she chooses to be a computational physicist? So there are three main subjects that one should study. Obviously, physics, one needs to understand the physics. That will be mainly for application. Then mathematics is also important because most of the theories are based on mathematics, and also one needs to understand computer science because they will be using hardware and software to do the work that they do. So these are key things that one should consider if they want to become a computational physicist. And there are cases where, or recently we have seen people who studied chemistry and biology doing computational work. We have the so-called computational chemistry, computational biology. And as I said, all those, they are underpinned by the laws of physics. However, what I wanted to highlight on this slide are the different careers that one can follow. So in addition to the obvious one where you can be an academic, that is being a lecturer, a professor, or a researcher, or one can be a civil servant, meaning that they work for the government. One can apply computational physics in any of these technological areas, as I showed or as I mentioned before. With computational physics, you can work in medicine and health sciences, you can work in energy security, you can work in advanced manufacturing, you can work in banking and finance, material science, mining and mineral beneficiation. So the importance here is that the skills that one acquires as a computational physicist, it can be applied across the different fields. And now moving closely to what we do in our research. So the research that we do is mainly based on, we call it materials modeling. Other people call it material science. So it has to do with calculating properties of materials, predicting properties of materials, improving properties of materials, using the different techniques or the different theories that are out there. This can be done on any kind of material that one can think of. And some of the properties that we are able to predict and calculate as computational physicists, it will be your energetics, dynamics, mechanical properties, structural properties, interfacial magnetic properties, optical properties, thermal properties, electrical properties, as well as transport properties. And if you look at these properties here, those who are studying physics, they can see that even though it's a combination of material science and physics, you can see a lot of physics coming up on the screen here. The same for chemistry. So you can look at these properties, but the interest being mainly from the chemistry point of view. Meaning that in chemistry, if we in physics, we will look at the interactions between the electrons, whereas in chemistry, someone might be interested in looking at these properties, but using approaches that are focused on the interactions between the atoms instead. And these are some of the work that we did. I'm not going to go into the details of the work, but I just wanted to highlight that we have, in collaboration with the University of Venda and the students, some of them are here. We have been working on energy storage materials, particularly on renewable energy or solar cells materials. And these are some of the work that we have done over the years. And we also did some work on energy materials, in this case focusing mainly on batteries, and these are some of the outputs that we have come up. And on the slide highlighted here is the collaborative work that we did with the experimentalists, what happened is that they synthesized these materials in the laboratory, and they found that they seem to be having some interesting optical properties. And what we did was that we developed models that represent these materials and calculate those properties, either to validate, verify, and also look at the in investigating some conditions that are not possible to do in the laboratory, and we're able to publish the work together. So that's what we did on batteries. Then we also did some work on photocatalysis, and again this was a combination of experiment and computational work where they synthesize the materials in the laboratory, then determine their properties, and what our contribution here was to predict the reaction mechanisms that occurs, and that work was published as well. Then we also do some work on energy storage materials, particularly on fuel cells, where we try to come up with materials that can function better than what we already have. And in this case, we develop some interfaces between palladium and MOFs. And okay, what is in the literature is that in fuel cells they use palladium and MOFs, and what we did was to introduce tin dioxide to see what will happen if, instead of just having the normal material, which is composed of palladium and MOFs, what will happen if we include the tin dioxide. And we realized that the stability of the material was better, and it improved the hydrogen-oxygen reactivity. So this we were able to simulate. And this is on the cover page is the work that we did was selected as a cover page for one of the journal Chem Electrochem in 2020. And moving to the future, which I felt that I will have to add this little bit here, because that's where the future is going, as we have seen from the fourth industrial revolution. So what we have been doing in recent past, or in the past 2 years, is that how do we've been doing modeling using traditional methods of computational modeling, but then the idea now is to move forward and incorporate the artificial intelligence into our research. And in this case, what we do, we wanted to see whether we can use machine learning models to predict properties of materials, as well as to come up with new materials that are not existing. And these are the different areas that one can explore in this field. It's a fairly new field, especially coming from material science. It is well established in other fields, such as your forecasting and games, the video games. However, in material science, these machine learning techniques are not fully exploited. So these are the different areas that one can look at. You can develop interatomic potentials of materials. One can design and discover new materials using these artificial intelligence techniques. One can also extract knowledge via text mining. One can do materials characterization. One can predict properties, and lastly, one can accelerate and improve the simulation that we normally do using the traditional methods. That will be your ab initio methods. So using machine learning methods, one can improve this simulation, especially in terms of speed of getting the results. And this is some of the work that we did, or the early work that we did, where we use the information or the data from the simulations that have been done over the years. We use that data as our input data and do the so-called feature engineering to understand what are the features that are important in our models. Then we were able to develop machine models which were able to predict the voltage of these materials, and the different algorithms predicted the properties differently, and we were able to know or identify the model that is good in predicting a particular property. And that's what we are showing here. So below we've got the support vector machines, we've got the random forest algorithms and the linear algorithms, and you can see that the linear algorithms has did not perform well compared to the other two. And the obvious reason could be that because it is meant for simple problems, whereas the type of problems that we do, they are generally complex. And between the two, we found that the random forest tree was the best model to predict the voltage of these lithium-ion battery materials. And this speaks to feature engineering, as I mentioned in my previous slide, that it is important to understand which of the features play a major role, because if you have that feature as an input, then it does not have an impact on how the model behaves. It will not help. So using this machine learning techniques, we are able to identify features that are important in our simulations. And in conclusion, I'm hoping that in the past minutes that I was speaking, I was able to at least indicate that the basic sciences are the heart for sustainable development, and we need them collectively to improve the quality of life. And also from the few examples that I showed, even though I did not discuss them, I believe I was able to show that using computational physics, we are able to discover new materials. We are able to discover new properties of existing materials, improve properties of existing materials. And there are several areas where computational physics has proved to be successful. This will include the studies on crystal structures, phase diagrams, materials properties, structure property relationships, the development of interatomic potentials, mapping of complex behavior of process variable. And lastly, I just want to highlight that with the drive for fourth industrial revolution, the increasing amount of scientific data invites all of us, either the theoretical, computational, and experimental scientists or physicists in this case, to explore the area in the fourth industrial revolution. And I would like to thank everybody for listening to my presentation. Thank you.
Thank you so much, Prof. Mapanga, for this wonderful presentation. We shall now dedicate this time for questions, answers, and comments to all the audience. will you be taking your people, or must I talk to them as they come with questions?
You can take them. You can take them.
Okay. Yes. First, I'm going to take Joe.
Yeah, okay, yeah, Solomon.
Okay, go ahead, Joe.
Okay, no, thank you. Thank you, Chair. And thank you, Professor Mapanga, for such scintillating, very vibrant talk, which you really intentionally wanted to make sure that it speaks to the purpose for basic sciences for sustainable development. And you started, of course, by explaining what are these sustainable development goals, which some of us may just read in a chart but not really follow. So thank you for that. So mine was just a comment that you've made things so easy so that we all understand, and I'm sure we all benefit from now mapping the real purpose of this webinar to basic sciences, which you elaborated in great detail. Thank you so much.
Thank you, Dr. Jason.
Wokedzi. Wokedzi, I can see you are raising up your hand. Can you?
Okay, thank you, Mr. Ravendani.
Okay.
We have two learners with questions. So you can go ahead and ask the question.
Okay, you're speaking to Baloyi Basani Eni from Pipihlengwane that is situated in Green Farm in Malamlele. The question that I have for you is that you said that physics plays a major role in sustainable development. Am I right?
Yes, that's true.
So I wanted to ask, what are the advantages of sustainable development and the disadvantages?
The advantages are that remember, the idea here is that we should not harm the world, we should not harm each other. So the advantage is that if we make sure that we keep our environment safe, the future generations will not have to suffer. I would give an example of the energy crisis that we have. So maybe 200 years ago, nobody has ever thought that there will be a time in South Africa where we have the so-called load shedding. And load shedding, it is here because the coal that is used to produce energy in our country is depleting, meaning that it's reducing every day, and we do not have enough to provide for everybody. And that is because while the resources are depleting, the population is growing, so it is not able to meet the energy demand for each and every one of us. But if at the beginning or 200 years ago somebody has had a thought that we need to make sure that the way that we generate energy, it is sustainable, so that in the next 1,000 years there will be no challenges, people would have conditions to think along the sustainability. But that was not a big thing then. Hence, everybody was doing what they were doing without worrying about the future, without worrying about harming the environment. And I think that's that could be a disadvantage, that it took so many years to realize that all the activities or all the technological activities that we do, they should be sustainable, meaning that we should be concerned about the sustainability. So I think I'll just stop here. But it's a it can be discussed broadly in many ways from different angles. The idea is to understand that going forward, we need to make sure that all the economic activities that we do, we consider sustainability, meaning that we need to make sure that we do not harm the environment, we do not harm the next person, and in that way we will live in peace.
Okay. Also, do you think that development, or do you think that the development that is happening is harming the environment?
Many of them they do, and I'm sure those who have been here for long, the older people, they will be able to cite some of the examples. So maybe 200 years ago there were less than 500,000 cars in South Africa. Today, each and everybody, if not, okay, most of the people, they have cars. And we know that these cars, they emit carbon dioxide, which harms the world. So if maybe at the beginning, the government had said that we are not going to have this many cars, instead we'll have a reliable transport such that people will not have to worry about transportation, then we wouldn't be where we are today. So that's another example on thinking about sustainability.
Thank you.
Yes.
Yes, Prof. Maybe I could, you say that other people who saw things earlier
Yes.
could also give an example. I'm one
Yes.
of them. I remember when I was growing up, there was a lot of forests. There were so many trees. And then our parents would just clear them in order to burn them and get a farmland. So huge, useful timber would be felled and burned because nobody knew that those are resources that cannot be replaced.
Yes.
Yes, and they were destroyed just to get a small farmland, maybe 1 acre, and every family was doing that. And now, what we have no forest cover. Similarly, for the animals, they would kill all the cheetahs, the leopards, and whatnot, because they didn't think that time would come when they could be almost extinct. So it was a very, it was a method, of course, which was never sustainable at all.
But on that one, I think this was maybe of a catch-22 situation where they needed to have food. And for them to have food, they had to cut those trees. Maybe they cut too much instead of just having enough land to provide for them.
Yes, yes, and of course, lack of knowledge also, yes.
Yes.
Voputu and Vokedzi, are you done there on the ground?
One more question from the learner.
Okay.
Okay, my name is Salati. My surname is Dembe from Computational High School during grade 11. My question is, what is computational physics and what are the stereotypes that you can come across?
Okay, computational physics, as I tried to explain, it's a third category of physics. We've got a theoretical physics, we've got a experimental physics. So in theoretical physics, it's more about researchers deriving new theories or improving the theories that have been there. Whereas in experimental physics, it's like when you go to the laboratory at your school and you do experiments. So the computational physics, it's the third category, and the difference between the theory, experiment, and computational is that we do not do the experiments, the physical experiments with computational physics. Instead, we use computers to do experiments. So we take the theories that the theoretical physicists develop and the experimental information that experimentalists develop and use them to build the so-called models. And we put those models into computers to do the experiments. Those experiments, we call them simulations. So it is just another another way of doing physics using computers instead of the equations and the experiments in the laboratory. So that the misconceptions, I think, I would think of the common one that are applicable to physics in general, to say that there are people who believe that the subject is difficult, which I personally don't think it is difficult. What is important is for somebody, especially the learners, to give themselves time to learn and understand the subject. So that's the misconception that I can think of. The other one that normally comes up is that the physics in general is for males. So I am against that, because I know a lot of females who studied physics and they have careers in physics. So those are the two misconceptions that are, or stereotypes that I can think of quickly. Thank you.
Yeah.
And maybe just to add that because everything is moving into using computers in future, it might be a great opportunity for learners to follow career in computational physics, because there will be time where everybody has to understand how computer works, meaning that even from the science, there will be a time where and it is already happening in other fields of science as well, in chemistry. Instead of going to the lab and do the different samples, they would instead use a computational chemistry to do the test. And once they know which of the concentrations work better than this, then that they will go back to the laboratory and do the actual synthesis of the materials. So it is the future, in fact, especially for the young ones. It fits into the fourth industrial revolution technologies, particularly on modeling and simulations.
Looks like there are no more hands. And in the absence of
Mr. Ravengan, there's one more.
There's one more. Okay. I can't see the hand. Who's that? Oh, from Okedzi.
Yes.
Okedzi, do you still have one more?
My name is Dr. Gift Mademba. I have a question for you.
Okay.
If I can recall correctly about what you have said, I remember you saying that in sustainable science or sustainable development, we're talking about the development of the world. And I remember you mentioning that in the future there will be development of AIs. AIs, I'm talking about artificial intelligence. Wouldn't that have a major downfall for people who are working?
Not really. I think most people, when they hear the word AI, they think of the robots that will come and take their people's jobs. So AI is not necessarily about the robots. It involves so many things. As I mentioned, that modeling and simulation is one of them. Internet of Things is one of them, meaning that there will be demand for people with those skills. There will be demand for people with cyber security skills, cloud computing skills. So it's not like it's going to replace what we have now. And it's, for example, I always give this example that people think that when we have these robots, they will take people's jobs. Even if I have a washing machine at home, which might be considered as a robot, I still need someone to operate that machine for it to clean the laundry. It will not go into my bedroom and take all the laundry and put it in the machine. So there should be a helper in the house to come and pick the clothes, put them in the machine, and let the machine do the clean. It's not necessarily going to replace all that we have, but it's going to improve what we have. That's how I view it. I can give other examples, but I'll stop here maybe for now.
Umrazi.
Good day, Prof, and thank you for such a wonderful presentation indeed. Mine is not something like a question, but maybe to also include these learners who have joined us. We also have Dr. Nemangwele in another school. If he is hearing me, if you do have some learners who are having some questions, please just let them ask these questions if they are there. Prof, especially when we are looking at computational physics, is integrating a lot of things.
Yeah.
How can a learner who is either in grade 10, 11, or 12 be able to join this let me just call it consortium, like the computational one, if he's still studying now?
I think the learner has to do maths and pure mathematics and physical science in school and pass them very well. I think if you get 7s, it will be great. But I guess in some cases they accept level 6. So you have to pass your maths and science very well in high school. Then when you go to tertiary, you enroll for, I wouldn't say Bachelor of Science. It could be any degree, but one will need to measure in physics. You can measure in physics, chemistry, maths, applied maths, computer science. And today I even see people who did engineering branching into computational. There's another term called computational modeling. So computational physics is it has to do only with the physics part of computation, but computational modeling, it could be in any field that you can think of, starting from health, finance, and any other field, physiology, any other field that you can think of. So what is critical is to pass your grade 12 with maths and science very well. Then when you go to tertiary, you do either natural science degree or engineering degree. Then when you go to your honors, that's where you start to specialize. Then if you want to be a pure computational physicist, then you will have to do honors in physics, then your master's in physics, PhD in physics if you want. And when you do those, you will need to because there are different